So let's look at the following example that deals with momentum. Let's suppose that we are given the following function that gives us the momentum of our object with mass 2 kilograms as it moves along a path. Now we want to calculate, using this function, the force function with respect to time and find the magnitude of the force at time equals 2 seconds. So let's begin by recalling that if we take our momentum function and we take the derivative of the momentum function with respect to time, that will give us the force, the net force of our object with respect to time. So we simply want to take this function and take the derivative of it with respect to time. And so because we have three different components, we have the x component, the y component, and the z component, we have to take the derivative of each of these components. And we get the following result. The net force on our object with respect to time is equal to, so 5t squared becomes 2 times 5 times t, so 10t I hat, plus 6t simply becomes 6j hat, minus 6 becomes 0, so this term, the z term, disappears. And this becomes our function, our force function with respect to time. So the force function is equal to 10t I hat plus 6j hat. So let's go to part B. Now we actually want to calculate the magnitude of the force at time equals 2 seconds. So we take this function, force function, that we obtained in part A, and we plug in our 2 into our function. So f of 2 is equal to 10 times 2 I hat plus 6j hat. So this becomes 20 I hat plus 6j hat. Now, to find the magnitude of this function, of the force function with respect to 2 seconds, we simply have to take the square root of the sum of the squares. So our 20 squared plus 6 squared, take the square root of the sum, and we get approximately 20.9 newtons. So the force acting on our object as it moves along the pathway at time equals 2 seconds is approximately 20.9 newtons.